Hi everyone. In this video we will learn about radioactive decay. Radioactivity is a process on its own that I will explain in a few minutes. But it is in your book in reference to page 105, 107. We will learn how to make a foldable on this. So for the foldable, of course, you need a piece of paper and we need to fold it. So take a piece of paper, and the long way, just like a hot dog fold it in a half. So it should be a long side, that you're folding. Once you fold it, you need to divide it into three sections. Fold it we actually need to make three sections of this. So you have 1, 2, 3 flaps, and then you can keep the lower flap as it is, but maybe you can cut the upper flap into three things. Or you can do the however you like it. But I would suggest just cut the upper flap, and then on the upper flap you're going to write on one side alpha, beta, and gamma. For the alpha you're going to do this, like that. For beta it's like a B, but you just finish it like on the top, and for gamma it's like a small R. So you label the three flaps. So you have three flaps right here, alpha, beta, and gamma. I believe you have cut these three flaps, and the bottom part is contact. You can pause the video if you like to get the work done. Now open the paper and copy the questions inside the flap. So upper part of the flap, underneath the alpha, you can copy what is the symbol for, what is the overall charge, and what is the mass in AMU. And these three questions will go for all three of them. Okay, once you finish writing it, and what are the subatomic particles associated with this radiation. On the bottom half, you will use your textbook to answer the questions from page 106, 107. So once you do that, we can move forward. That's all. You can pause the video, as I said here, and take care of this. Make this foldable, cut it into half, label it on the upper side of the flap. Not on the bottom side. On the upper side of the flap, you need to write the 4 questions and then get the answer from the book. So once you get this work done, please come back and listen to it again. All right, let's talk about, if you've already, I assume that you've already done the work. Let me talk about, first of all, what radioactivity is. Radioactivity is a natural process. And why does it even happen, and what is it? In the periodic table, there are 12 elements. But for the elements from atomic number 1 to atomic number up to 20, the number of protons and neutrons in the nucleus are same. 6 protons, 6 neutrons. 3 protons, 3 neutrons. 20 protons, 20 neutrons. But as you get into the higher elements, like especially bigger elements, uranium 92, 238, you have 92 protons, but what is it, 146 neutrons. So do you see that there's a big gap between number of protons and neutrons? And elements don't like that. Atoms don't like that. They like to have equal number of protons and neutrons to stabilize their nucleus. So since they don't have equal number of protons and neutrons, when you go to the heavier element, they give out radiation. The nucleus is continuously giving out radiations. So the nucleus of uranium, who has 92 protons and 146 neutrons, is constantly giving out rays. Sometimes it's going to emit protons, sometimes it's going to emit neutrons, sometimes it's going to emit electrons, positrons. So it's going to do all that just to get the equal number. Not that they get it, but that's a natural process that's happening. So since the rays that come out are called radiations, and the process is called radioactivity. So radioactivity is a natural process of any element to emit to give out radiations. Do you understand this? Radioactivity is a process in which an element or atom gives out radiations. As I said, radiations comes out in the form of protons, neutrons, electrons, positrons, and much more. But common sense is that if it gives out protons, it will turn into a different element, because protons is the identity of the element. So I will not go too far, stay on the topic. So this is the radioactivity. Radioactivity is a natural process, and all those elements who have the ability to go through the radioactivity are called radioactive elements. The elements at the bottom here are also radioactive elements. Okay. When we're writing, we will learn how to write that radiation. When this element give out a certain radiation, what happens to it? So there are different types of radiations. There is one type is called alpha radiation. There is one type that's called beta radiation, and there is another type that's called gamma radiation. So there are three different types of radiation that you just make the. Alright, so I just explained what the radioactivity is, and let's talk about the three radiations. I'm sure you've already taken notes to answer those 4 questions, but alpha radiation, let me explain what it is. Alpha radiation is, we call it a helium nuclei. Why do we call it a helium nuclei? Because whenever any element, any X element, gives out 2 protons and 2 neutrons, we say an alpha went out. If I have 2 protons, that means the atomic number of that X is 2, because proton is the atomic number. So if I give out 2 protons, atomic number is 2. And if it's 2 protons and 2 neutrons, and together it makes the mass. So if we go to the periodic table, this is the kind of specification for the helium. Helium is atomic number 2, and the mass is approximately 4. Okay, so that's why we call it a helium nuclei. So whenever an alpha goes out, alpha is a helium nuclei. So if I have any element that has, let's say it is carbon, and I say that carbon went through alpha radiation. Okay, carbon went through alpha decay, I should call it alpha decay, because it is going to lose its mass, so it's decaying. So alpha decay means it has given out alpha particle. So if it has given out alpha particle, we need to make sure we balance the equation. Okay, so this was the element, it gives out, okay, in the product 1 alpha particle. So what is left behind? I need to do the math that what is left behind. So 6 minus 2, because 6 it went out, so 2 protons are lost. So how many protons left? 4. And how many neutrons left? 8. So now I need to go to the periodic table and see who is the element with atomic number 4. Do you know who is the element with atomic number 4? It is beryllium. That means when carbon goes through alpha decay, it turns into beryllium. Now if beryllium, let's say take another element, let's say take beryllium. Let's say you take, let's take a bigger element, sulfur. So sulfur atomic number 16, atomic mass 32. If it gives out an alpha decay, actually I should not be giving you an example, let me give you a bigger one. Uranium 92, 238, okay, it gives out an alpha decay, it gives out an alpha particle. So what happens is that 92 minus 2 is 90, and 238 minus 4 is 234. Now I need to go to the periodic table, because identity of the element is the atomic number. So I need to go to the periodic table and find out who is 90. So if I go to the periodic table, I find out that atomic number 90 is thorium. Alright, if thorium gives out another alpha particle, what would you do? You do the math again. Okay, it will do 90 minus 2, it's 88, and it is 230. So now I have to say, okay, who is 88? So you go to the periodic table and look for 88. 88 is radium. So it can keep going this. Uranium gives out one alpha and turns into thorium. Thorium gives out another alpha and turns into radium. So this is called decay because element is decaying into another element. Anyway, you have to understand what alpha is, and alpha is a helium nuclei and it is 2He4. Now what is a beta? Beta is a positively charged, beta is an electron. Okay, it has a mass of 0, but it has a charge of -1. Okay, so we call it a beta particle. So it's a lightweight particle. It can go quite far because it's lightweight mass. Alpha is very heavy particle. Okay, it is very heavy particle. It will not travel too far because it has a lot of mass. Anything that has a larger mass doesn't travel too far, so it doesn't penetrate very much. So if we throw alpha particles, even a paper can stop it because alpha particles are very heavy. On the other hand, beta particles are light. Okay, it's lightweight, and since it is lightweight, it can penetrate much deeper. Okay, and travel quite far. So again, this is beta, and it is an electron. So it has more energy than alpha particle. So when beta goes out, let's say you have, I'll take uranium again. So if uranium, instead of giving out alpha, it gives out a beta particle. So beta does not have a charge on itself, you know. So there is no charge, there is no mass. So the mass will stay the same, but I have to subtract one atomic number. So 92 minus 1, but you have to, it has given out an electron, so the atomic number will go up. The number of protons are increased. So when it will go out, the atomic number will go up. It will become 93. So I have to see who is 93 because 93 minus 1 has to be 2. You have to do the math. 93 minus 1 will be 92 if you know algebra. So now you have to go to the periodic table and find out who is 93. So let's do that job. I'll give you that job to do that. Okay, so let's take another example that you take, for example, maybe plutonium. So I have Pu 94, and its the mass is 244. If it gives out a beta particle, okay, the mass will not change. It's 244, all right, but this one will go one number up from 94. It will go to 95, and I go to the periodic table and find out who 95 is. So you need to understand that you have to balance these nuclear equations, that this minus 1, 95 minus 1 is equal to 94. So this is called balancing nuclear equations. Okay, you also need to learn their properties. As I told you earlier, that alpha particle is a heavy particle, beta particle is a lighter particle, and the other one is called gamma rays. Gamma rays are energy waves. Okay, so when energy goes out, nothing happens, no change happens. So if uranium 92 238 goes through a gamma radiation, there will not be any change. It will still be uranium. Okay, so it will not make any difference. It will still be uranium. Nothing would happen again. So, but usually gamma radiations don't go out just by themselves. Gamma always comes out with some other sort of radiations. So what happens is that when uranium gives out alpha particle, which is 2He4, and it is going to turn into what? You tell me. 90 and 234, right? And 90 is thorium. At that time, gamma also goes out. So gamma always is attached to some sort of radiation. It comes out with alpha, it comes out with beta. So, but gamma itself is only energy, And it is, since it's only energy, no mass, no atomic number, it is very, very uh, penetrating. It will penetrate, it can pass through your body, and it can damage it very well. So it is, I should say, pretty badly. So there, anyway, this is the bottom line. We learned about three types of radiations: alpha, beta, gamma. This is helium nuclei, okay, 2He4. This is an electron, and this is just energy. This is very heavyweight. This is lighter than alpha. This is very, very lightweight. This one does not penetrate very well. It penetrates, it can penetrate quite a lot, and this can even pass through the body. So we have to be very careful. And all of this is happening to get the nuclear stability. Okay, because when number of protons and electrons are not equal, nucleus will give out radiations, and those radiations come out in these forms, and the process is called radioactivity. So that's all we want to learn in reference to radioactivity. All right, everybody, thank you.